Hey guys, my name is Tin and today I'll be doing a Physics C circular motion and gravitation problem. Okay, so let's read the problem. A typical laboratory centrifuge rotates at 4,000 rotations per minute. Test tubes have to be placed into a centrifuge very carefully because of the very large accelerations. What is the acceleration at the end of a test tube that is 10 centimeters from the axis of rotation? For comparison, what is the magnitude of the acceleration of a test tube would experience if dropped from a height of 1 meter and stopped at 1 millisecond or 10 to the negative 3 seconds and counter with a hard floor? Okay, so here I have a diagram of the centrifuge. As you guys can see, this is the center of rotation and the acceleration goes into the center of the rotation. And here's the velocity as the centrifuge is spinning. Let's identify the variables that are given by the problem. So we have frequency of rotation, which is 4,000 rotations per minute. However, this is not the unit that we want. We want it to be in second. So we convert it to second, and we have 4,000 rotations per minute. In order to get rid of the minute in the denominator, we have to multiply it by minute, and 1 minute is equivalent to 60 seconds. 4,000 divided by 60 is equal to 66.7 rotations per second. Next, we have radius. The radius given is 10 centimeter or 0.1 meter. We have period. Since the period is the reciprocal of the frequency, we have 60 over 4,000, and 60 divided by 4,000 is 0.015 second. Now that we have identified all of our variables, let's look at the relevant equations for this problem. We have the centripetal acceleration equation, which is v squared divided by r, where v is the velocity and r is the radius. Second, we have the centripetal velocity equations, which equals to 2 pi r divided by t. T is the period. Finally, we have the period equation, which is t equals to 1 divided by f, which is the reciprocal of frequency. Since we already have the acceleration and the velocity equations, we can combine them to come up with a new manipulated equation. So, when combining the velocity equations into the acceleration equations, we have accelerations equal to 2 pi r divided by period r raised to the power of 2 divided by r. To simplify this equation by distributing the second power, we have 4 pi squared times r to the second power divided by frequency by the second power. When dividing a fraction by a number, we actually multiply it by the reciprocal of the number. So in this case, we multiply the fraction by 1 over radius. So as you can see here, we have radius here and we have radius here. So those two cancel out, so we're left with 4 pi to the second power times r divided by period square. Now all we have to do left is to plug in our variables into the manipulated equations. So we have acceleration equal to 4 pi squared times 0.1 divided by 0.015 to the second power. If we plug that into our calculators, we have 17,546. However, since we only need 2 significant for this problem, the answer would be 17,000 meter per second square. Now, let's look at our given variables in part B. We have height, which is 1 meter. We also have time, which is 1 millisecond, or 10 to the negative 3 power second. Okay, now let's look at our relevant equations. We have accelerations equal to delta v divided by delta t, where delta v is is the change in velocity. Final velocity subtract initial velocity. And time is just the time the centrifuge takes. Lastly, we have a kinematics equation. V squared equals to V initial to the second power plus 2ax. Okay? So first, let's manipulate the kinematics equation to find the final velocity. Since the centrifuge starts at 0 meters per second, we don't need the initial velocity, so we can cross that out. Left with v squared equals to 2ax. And if you guys take the square root on both sides, we're left with v equals to the square root of 2ax. In this case, we don't have acceleration. Well, we do have an acceleration, but it's gravity. So we replace the a with a g to indicate that's just gravity. We also don't have a displacement, but we have a height. So we replace it with an h. Now all we have to do is to manipulate our new equation. Since we know that the acceleration equation is delta v divided by delta t, we can plug in our previously manipulated equations for final velocity into our acceleration equations. We have final velocity subtract by initial velocity, and again initial velocity was 0, so we don't have to write that, but I just wrote it to be sure. So we have accelerations equal to the square root of 2gh divided by the change in time. Now that we have our manipulated equation for acceleration, all we have to do left now is to plug in our variables into the equation to find our answer. So we have the square root of 2 times 9.8 times 1 divided by 10 to the negative 3 power. So when you plug in everything into the calculator, you get 4,422 meters per second square. And again, since the questions only require you to have 2 significant figures, you can write your answer as 4,400 meters per second. Either one is fine. Alright, thank you for watching.